video, we are going to look at ionic bonding. So the first example that we're going to look at is what happens when lithium bonds with fluorine. We would also obviously need to know what the formula is of the product that is formed. So in order to do that, we're going to use our periodic table and we're going to use the electron structure. So I've drawn already the structure of lithium with its 3 electrons and fluorine with its 9 electrons. And we're going to use this fact to help us work out how it bonds. So we know that electrons always want full outer shells. I'm going to write that down here because it's really, really important. Atoms want full outer shells. This is really, really important. So how do we get lithium to have a full outer shell? Well, it would be really easy if we could lose 1 electron. How do we get fluorine to have a full outer shell? Let's count how many it has. 1, 2, 3, 4, 5, 6, 7. It's got 7 electrons. It needs to gain 1 more to have a full outer shell of 8 electrons. So maybe you can see what's going to happen here. Wouldn't it be great if we could make lithium lose this electron and give it to fluorine? So now that would solve both of our problems. Lithium would have a full outer shell. It would have lost its 1 electron, and fluorine will have a full outer shell. It will have gained 1 electron. So that's exactly what is going to happen. So we can draw lithium with its now full outer shell. And you might remember from my previous video or class that it's now got a charge. It's lost an electron, so it's become positively charged. Fluorine, what's happened to fluorine? Well, now it's gained an electron. So let's draw its electron structure. Now I'm going to just draw it in orange to show that it's come from lithium. You don't have to do this, but it is quite nice. So it shows you that it's this one that's moved over. It's gained an electron, so we can draw our square brackets and we can say it's got a negative charge. So these are now what we would call an ionic bond, or they are bonded ionically. What does that mean? It means there's 2 ions, an ion and an ion, a positive ion and a negative ion. And we know that positive and negative attract together. If there were 2 positive ions, they wouldn't attract, they would repel. If it was 2 negative ions, they would repel, because it's positive and negative, they attract. So what do we notice? We've got 1 lithium, 1 fluorine, so it's going to form lithium fluoride, 1 of each. Now, if we're going to do this 100% properly, we should know that fluorine always comes in pairs. So actually, we should write this. And we could also balance it. So there's 2 here. There's only 1 fluorine here. So we should put a 2 here. So now there's 2 fluorine. There's also 2 lithium. So we could actually write a 2 here to balance this. Now, you might say, well, hang on a second. I've only done 1 lithium and 1 fluorine. Shouldn't I do 2 of each? And the answer is, maybe if we want to really show this. But the questions that you will get only ever ask you to show 1 example, all right? Because, we could copy the same thing out again, but there's not really any point when we've shown this. So here's a second example, magnesium and oxygen. Pause the video now and try this question in exactly the same way I've done this. So first step we need to draw magnesium and its electron structure. So in order to do that, we need to look at the periodic table. We need to locate magnesium with its 12 electrons, and we need to draw that in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it's going to have a 3rd shell with 2 electrons in. Oxygen, again, we look on our periodic table, it has 8 electrons. Oxygen is going to look like this: 1, 2, 3, 4, 5, 6, 7, 8. And we need to decide what the easiest way is for both of them to have a full outer shell. So we see that magnesium has got 2 in its outer shell, so it could gain 6, but it's actually far easier if it were to give its 2 electrons to oxygen. and oxygen, it could lose 6, but it's far easier for it to gain 2. So now we can draw our ion or our ionic bonded molecule in this same way. So we can draw magnesium. It's now only going to have 2 shells because it's lost some electrons, 1, 2, and then it's going to have 8 in its outer shell. And it's lost 2 electrons, so it's going to have a positive 2 charge. Oxygen has now gained 2 electrons, so it now has 8 in total. And again, I'm just going to draw them in purple to show that they're actually magnesium's electrons, and it's gained 2 electrons, so it's got a negative 2 charge. You'll notice these obviously balance. There's 1 of each, so we can just write magnesium oxide there as 1 of each. If we wanted to balance this, we could do it in exactly the same way. We know that oxygen really does come in pairs, so we should write this, which means there should be 2 of these to balance the oxygens and 2 of these to balance the magnesium. Okay, let's do 2 slightly harder examples now. So the first one is beryllium plus fluorine. Pause the video now and work out how this will bond. So beryllium, when I look at my periodic table, I see that it has 4 electrons. So it's going to have 2 in the first shell. It's going to have 2 in the second shell. Fluorine has 9 electrons, looking at my periodic table. So it's going to have 2 in the first shell, and it's going to have 7 in the outer shell. So how can we make these have full outer shells? Well, beryllium needs to lose both of its electrons. Fluorine only has space for 1 electron here. So we can move 1 over, but what are we going to do with the other one? Well, we're going to need a second atom of fluorine so that the second electron can go to the second atom of fluorine. So we're going to add a second fluorine, and this second electron can go to the second one over here. So now this one will have a fluoride shell and this one. So let's draw this and see what it looks like. Beryllium has 2. It's an ion, so we always draw square brackets. It's lost 2 electrons, which means it's positive 2. Fluorine, we now have 2 fluorine. So I'm going to draw 1 over here and 1 over here. And it has now full outer shells. So it has 2 shells. This one has 2 shells. And we know how many electrons it's going to have. And again, I'm going to draw them in purple so you can see that 1 has gone from the beryllium to each one. They've both gained 1 electron, so they are both negative 1 charge. And what do we notice? There is 1 beryllium and 2 fluorine. So we could write in BeF2. And we can also just check 2 plus, minus, and minus, they balance out. Let's see if we can balance this equation as an extra challenge. Well, we know that fluorine should come in pairs. That's how it always would come in nature, in the world. So actually this now is balanced. All right, final example for this video. Pause the video now and try this question. So let's draw sodium. Looking at my periodic table, I know that it has 11 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And oxygen has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. What's the easiest way to form an ion? Well, sodium has 1 in its outer shell, so it'd be really nice if we could lose that 1. What about oxygen? Well, it's going to gain 1, but it's still missing 1 electron. So what's the solution? We're going to add a second sodium atom. We're going to draw that in. Sodium, 1, 2, 3. And that 1 electron will also move over. So now I can draw my ion. This time I'm going to choose to draw oxygen in the middle. And we know it's gained 2 electrons from the sodium. So I'm just going to draw this in a different color. If it's gained 2 electrons, then it's going to gain a -2 charge. And the sodium will have lost 1 electron, so it will have its full outer shell. And it's lost an electron, so it's going to have a +1 charge. There are obviously 2 sodiums, so I need to draw another one over here. Also with my brackets in, and I notice that the 2- is balanced by the positive and the positive. So what is the formula over here as our extra challenge? Well, we've got 2 sodium and 1 oxygen. We could now try and balance this. So oxygen always comes in pairs in nature, so we should write this. Is this balanced? Not quite. There are 2 oxygen, 1 oxygen, so we need to put a 2 here. Now we find we've actually got 4 sodium, so we're going to put a 4 here.